Welcome back. We're going to be looking at 4.3 in this lesson. So this video is going to cover decimal and percent section. So the word percent actually has Latin roots, and the Latin word is percentum, which means per hundred. So percent means hundredths, or the ratio of a number to 100. And we know ratio can be written as a fraction if we want to. So the symbol percent is the percent sign, and the sign has the same meaning as out of 100 or 1 over 100. So when we're looking at numbers, if you want to change a number that's written in decimal form to a percent, what you're going to do is multiply the number by 100, which means you're moving that decimal point 2 spaces to the right, and then you're adding the percent sign with it. But if you're given a percent and you want to write it in decimal, you're going to go backwards. You're going to divide by 100, which ends up moving the decimal place 2 spaces to the left. And then you'll get rid of the percent sign because moving that divides by the 100, which is the same thing as percent. So just move it and then add the percent sign. So let's look at some examples of changing percents to decimals. With our first one, we have 76%. So again, we don't see a decimal point, so it's understood to be at the end here. And percent to decimal, we're going to the left. And so we're going to divide by 100, which means you can just move the decimal 2 places, which puts it right here in front of the 7. So if you want to put a 0 in front of the decimal point, you can, or just put 0.76. For B, we have 18.5. So we have that decimal point to be able to scooch over to the left 2 times. So as a decimal, it's 0.185. And then for C, we have 50%. So again, there's our invisible decimal point to be able to move 2 spaces, which will give us 0.50. And that extra 0 at the end, we do not have to keep. We can simplify it if we want to 0.5, which shows a good thing to remember, that when we're going backwards from a decimal to a percent, sometimes we don't have enough spaces to be able to move. And so to percent from a decimal, we're going 2 spaces to the right. So notice there's not 2 numbers anymore because we dropped that 0. So then we would have to put a 0 for a placeholder to get that 50% back. 100% is the entire thing, which makes sense when we move that decimal to see that it's 1.00. Or again, we can drop those zeros after the decimal point and just say 1, the whole thing. And E is an example, again, where we have to add zeros. We have 0.25%. So moving the decimal once gets us in front of the 0. So then we actually have to add a second 0 in there to be able to put the decimal point in front of it. So we can write it as 0.0025, or again, you don't need the 0 in front if we want, just 0.0025. So here's a couple percents for you to practice changing into decimals. So pause the video and work on those. When you're finished, resume the video so you can check your work. Okay, here you go. Notice that for 40%, you can write it either as 0.40 or 0.4, and the rest are there. So let's go to our true-false statements. First one, if a decimal number is less than 1, then the equivalent percent will be less than 100. So hopefully you remember that that's true, that when we have a decimal with nothing in front of it, so then it's less than 1, we have less than 100% because 1 is the equivalency of 100%. Statement 2, it is not possible to have a percent greater than 100. Well, if that were true, then we wouldn't have questions like question B, where you just change 211% into 2.11. So that is false. It is possible. A decimal number that is between 0.01 and 0.10 is between 10 and 100%. Well, I see that that's false right away because 100% we know in decimal form is 1, but let's see what percentages we're looking at. So 2 spaces to the right gives us 1%. So that 10% is wrong. It should be 1. And then 2 spaces to the right here gives us 10. So 0.01 and 0.10 is between 1 and 10%. Statement 4, to change from a percent to a decimal, simply omit the percent sign or take it away. So if we look at this example we just did, taking away the percent sign from this 1% will give us 1, not 0.01. So that is false. And so we need to add a step there by moving the decimal place 2 places to the left and then omit it. I'm going to pause it so I can write that without you having to wait for me, although you can pause it and write it yourself and then continue. So again, we need to move that decimal 2 spaces to the left before we can take the percent sign off. So here's a couple of practice problems for you. Change each fraction to a percent, change each decimal to a percent, and then percent to a decimal. You might be saying, hey, we didn't cover fractions to percents, and we'll actually cover that in another lesson, but look at what they gave you. They gave you denominators of 100. Percent means out of 100, so what do you think that means as a percent? Let's go ahead and try it. Pause the video and then resume when you're ready to check your work. So did it make sense to you that we're keeping the numerator of those fractions as our percent since it's out of 100? I thought it would. So let's look at some application story problems. So where might we see some of these numbers in real life? So a savings account is offering an interest rate of 0.04 for the first year after opening the account. So normally we don't talk about interest as a decimal, we talk about it as a percent. So we want to change that into a percent. And so decimal to a percent, 2 spaces to the right, and add the percent sign, so we get 4%. When we're actually using mathematical calculations, we would change it to 0.04 before being able to multiply and stuff. So that's why they're having us switch between the two there. So we're going backwards here. If we're going to take sales tax of something, when we multiply, we want to multiply it by the decimal equivalency of 7.25%. And so we'll take our percent, and now we're going to go 2 spaces to the left and make it 0.0725. If you forget or aren't quite sure if you need to move 2 spaces to the left or 2 spaces to the right, go back to that idea of the number 1 is being equal to the whole thing or 100%. And that should help you double check yourself on which way the decimal needs to go. Okay, so what is that relationship between the percent and the number 100? You can pause the video and take a second to write down your ideas, and then you can see what I had in mind and check and see if you need to add anything extra to your ideas before going on. So here I have percent means per 100 or out of 100. This means that the number in front of the percent symbol is the numerator and 100 is the denominator when written as a fraction to show this relationship. And so 14 asks two things. Describe a situation where more than 100% is possible. Endless answers there. And describe a situation where it is impossible to have more than 100%. Again, endless possibilities. So try and rack your brain a little bit, brainstorm. Sometimes it's easier to think of something if somebody else gives an example first. So if you need to look at my example before trying to come up with one of your own, I completely understand. So pause the video and give yourself some think time. And then when you're ready, continue on. So retail is definitely where 100% is not the baseline of normalcy. And I mean because if somebody who owns a store or a company sells things at 100% of what they paid for it, then they're never making any money. They're actually losing money because they don't have any money to pay the bills and stuff like that. So they're going to purchase something at a certain dollar amount and then mark that price up or make it higher than 100% of their purchase price to sell it to us, so they're making a profit. So hopefully the retailers are always getting higher than 100% of their purchase price on their sale price. And then impossible to have more than 100%, my thoughts were containers. You know, the capacity, a container can only hold so much or so much liquid in this example. So you can't have more liquid inside of a container than it can hold. So if you have a can that has a capacity inside that can of exactly 12 ounces, no room for air or anything like that. Once 12 ounces are in that can, then trying to put more would just cause it to spill all over the place. So a container's capacity can have no more than 100% of what that container can hold. So that is it for 4.3. And if you have any difficulties with your homework on Hawks, again, don't hesitate to send me an email, let me know. And if you have no questions, then just keep going and I will talk to you next time.